Have you ever wondered how you get that instant notification when someone likes your photo? Or how your stock app knows the exact second a price changes? Well, the secret sauce behind so many of these real-time updates is a really powerful software design principle called the observer pattern. So let's dive into this elegant solution for keeping everything in sync.
Okay, so let's start with the problem that developers run into all the time. Imagine you have one object and its state changes. Maybe a new message arrives in a chat app. Now, how in the world do you tell all the other parts of the app that care, like the little notification badge and the main chat window, about this change? And how do you do it without creating a tangled, unmanageable mess of code?
Let's think about this with a super simple analogy. Let's say you really want that new iPhone. You've got two pretty bad options, right? You could waste your time and gas driving to the Apple Store every single day just to check. That's what we call inefficient polling. Or the store could just spam every single person on their massive mailing list every time any new product comes in. A new watch band? Spam. New laptop? Spam. Neither of those is a great system.
And that exact same dilemma shows up in code. It forces developers into this corner where they have to choose between constantly checking for updates, which waste resources, or building a messy system where everything is shouting at everything else.
So, what's the solution? Well, it's an idea that's actually super elegant and one you're already familiar with from your everyday life. It's a subscription model.
Okay, so here's the formal textbook definition. But what does that really mean? At its heart, it's all about creating this one-to-many relationship. You have one object, the one, and a whole bunch of other objects that are, watching it. And when that main object changes, all of its dependents get the memo, automatically. No fuss. Visually, it's really this simple. You've got a central object, we call it the subject. Then you have other objects, which we call observers. And they basically raise their hand and say, hey, I'm interested. They register with the subject. Then, when something important happens, the subject just sends out a notification to everyone on its list. And the really cool part? Observers can subscribe or unsubscribe whenever they want. So let's break down the key players here. First up, you've got the subject. Sometimes you'll hear it called the publisher. This is the star of the show, the one everyone is watching. Then you have the observers, or subscribers, who are interested in what the subject is doing. And hey, don't let the word concrete throw you off. That's just developer speak for the actual piece of code that does the work. It's the real thing, not just the blueprint.
So how does the code actually pull this off? Well, this diagram shows the formal structure, and here's the magic trick. The subject doesn't actually know any of the nitty-gritty details about its observers. It just knows they promise to listen. This is what we call loose coupling, and it's incredibly powerful. Why? Because you can create all sorts of brand new observers, and you never ever have to go back and change the subject's code.
All right, enough with the theory and the diagrams. Let's talk about where this pattern actually shows up in the real world. Because this isn't just some abstract idea, it's running silently inside the apps you use every single day.
And I'm not kidding. Once you really get what this pattern is, you are going to start seeing it absolutely everywhere. For instance, just think about it for a second. That notification you get for a new comment on your post, your profile is the subject, and the notification system is an observer. A stock you're watching is a subject, your app's alert system is an observer. That back-in-stock email you've been waiting for, same exact thing. Your route in Google Maps is a subject, and it's constantly being observed for new traffic jams. This pattern is literally the engine behind so much of the dynamic, real-time internet.
Okay, so we know what it is, and we know where it's used. But now let's peel back one more layer and look at a really key decision that developers have to make when they build one of these systems.
The big question is this. When the subject notifies its observers, how much information does it actually send? In the push model, the subject basically sends a whole package of data along with the alert, saying, hey, something changed and here's all the info. It can be really efficient if the observers are going to need that data anyway. But in the pull model, the subject just sends a simple ping, like, hey, just so you know, something's different. It's then up to the observer to ask, or pull, the specific data it needs. This is way more flexible because each observer can decide for itself what info it actually cares about.
Now, as powerful and as widespread as this pattern is, it is definitely not a silver bullet. And in fact, if you use it carelessly, it can create its own set of really, really tricky problems.
I mean, listen to this quote.
It's pretty intense, right? It comes from a paper co-authored by the creator of the Scala programming language, and it just highlights that the very flexibility that makes the observer pattern so great can come at a pretty significant cost.
So what are these problems exactly? Well, for starters, debugging can be an absolute nightmare. When something breaks, it's really hard to trace the chain of events because the subject just kind of fires notifications out into the void. You also can get unexpected updates. Since you have no idea what order the observers will be notified in, you can get some really weird glitches if one update accidentally depends on another one happening first. But the biggest trap of all is memory leaks. If an observer gets destroyed but forgets to unsubscribe, the subject will just keep holding on to it forever, and it can never be cleaned up by the system. That is a classic bug, and it can be a real pain to find.
So this all brings us to the fundamental choice a developer is making when they decide to use this pattern. It really boils down to a classic engineering trade-off.
Here's the bottom line, the thing you really need to remember. With the observer pattern, you get this incredible flexibility. The ability to add and remove new listeners on the fly without changing your main object is fantastic. But you pay for it with code that can be way harder to understand, harder to debug, and much less predictable in how it runs.
And that really leaves us with the final big question. In any situation, a developer has to stop and ask, is the amazing decoupling that this pattern offers really worth the potential mess and complexity it can introduce down the line? And the answer, like it always is in software, is it depends. Thanks for tuning in.